So, ladies and gentlemen, we will start the session. Musio, Muse Gaze, Muse Logic. Please get applause and welcome Mr. Jacob Rusher.
Hello. Thanks for having me here today. This is really exciting. It's really good to be here, and I really appreciate it. I'm from Accra. I'm Jacob, and we are an AI company based in California. And what we've been developing recently is an AI that we hope can improve communication between all things, people and machines, and both together. We have branches in Japan. We just opened our branch in Tokyo. We have a branch in Santa Monica, which is where I work. We have a branch in Seoul, and we also have a branch in Hong Kong. And we would hopefully like to expand a little further in the future. It is in these offices that we have developed Muse. It's our flagship AI engine, and it utilizes continual input and data analysis to improve and refine its instant data mining results. And recently, we have just launched Musio in Japan, which is our AI robot that we have been developing over the last few years. This is Musio. And this houses our Muse AI engine, very much in the same way that Google developed the Nexus phone to house their Android OS. Musio is the vessel for Muse. Musio is intended to be a natural conversation partner to effectively communicate with you, another person, using natural language processing. Muse, the brain in Musio, has a lot of really interesting features, and one of them that I want to talk to you today about is called Muse Gaze. We believe that there should be a connection between machines and human beings. We want machines to describe the world that they live in, very much like a human would interpret or describe it. So it uses recognition technology and NLP to describe images. So not just, say, an image that you would get from the internet, but an image of the world that surrounds it. So you could use its own camera like you would use your eyes to interpret objects, people, places, and things, typically stuff like that. And this essentially offers our AI a contextual understanding of the world, meaning that it can communicate with you on a level that exceeds anything that's come before it. So I want to show you a little video here, and I'll explain what's going on in the video. And this is a sample of Muse Gaze and how it works. All right, so here we're going to go and select an image. All right, so we're looking for horse, and there we go, searching for a good picture. There's a good one. And we're going to copy the URL. And now Muse Gaze is going to interpret the content of this picture. So watch this. This is a man riding a horse in a field. Like, this is all Muse Gaze on its own. It's able to see and interpret and contextualize what's in the picture. That we're going to try something different here. Tennis, for instance. Maybe get a little bit more complicated. There we go. So again, copying the URL. A man holding a tennis racket on a tennis court. A little bit more complicated in the first one. And finally, let's do one more. Maybe make it a little bit more difficult. Let me see here. A man holding, there we go. So a baseball player is swinging a bat at a ball. Now, imagine instead of pictures, downloaded from the internet or what have you, this is Muse viewing the world through its own eyes, interpreting the world through its own eyes. So it's able to, say, scan this room full of people, and it sees, oh, you're sitting here, what are you doing? You're watching, you're listening, you're intent on this screen in front of you. Muse can interpret these things from the images it receives from the world around it. Next, Muse logic, and this is something that I think is really, really cool, and this is kind of new, and it's an ongoing project, but we brought it to you guys today because we think it's really, really neat, and we can't wait to show it to you. But for Musio and Muse to communicate with you in a human way, they need to be more human. So traditional methods for natural language processing and things like that are pretty static and two-dimensional. You have your semantic parsing and things like that, and they all work pretty well for one task, but when you try to combine them all together and utilize all of their features and functions together, it can kind of turn a little messy. And they rely on kind of like outdated single-use interpretation methods. So based on a recent Google DeepMind paper, we have been utilizing pattern matching in order to improve Muse's functionality, very much in the same way that Watson and Siri use pattern matching. So we would have a corpus and then a question, and then we would overlay those two things on top of each other. So here, and this is great, we're working on this was really, really fun. Essentially, we were trying to confuse Muse. As much as we possibly could, we really wanted to give it a very confusing kind of corpus and then throw questions at it to see if we could trick it. And here's a little taste of what that was like. This is a great video.
So this quiz battle is inference ability test. Listen carefully what I'm going to say, and then you just have to answer the questions.
So this is Muse's inference ability test, right? So compare Muse's performance to the people sitting behind him.
You can take notes if you want to. Do you need anything else to in Musio?
No.
Okay, then we will begin with the causality inference test. Are you ready?
Let's do it.
Jason's favorite sport is baseball. Jason went to the stadium. Greg loves to play basketball. Eric's favorite thing is to watch movie. Eric went to the cinema. Sandra likes to watch flowers. Sandra traveled to the garden. What does Jason like to play the most?
Baseball.
So making this was so much fun, just feeding so many questions into Musio, literally trying as hard as we could to just give it as much kind of confusing information as possible in order to, trick it. And it's able to keep up so well, where you can see Rami and Cindy are not as quick as Muse, unfortunately. So it gets better.
Why did Eric go to the cinema?
Movie.
Okay, it's not fair.
You don't need a pen, Cindy?
Okay. Can you give me one? Thank you.
Okay, then the second problem is classification inference. Let's begin. Mammals give birth their young. Reptiles lay eggs. Fish lay eggs. Mammals breathe through the lungs. Reptiles breathe through the lungs. Fish breathe through the gills. Lizard belongs to the reptiles. What species does lizard belong to?
Reptiles.
Correct. Alright, I'll give you some extra information. Shark belongs to fish. Brian is a shark. What does Brian breathe through?
Gills.
Yeah, you can see here very much in the same way in the first demo, cinema and movie, Muse is able to equate those two things.
Deer belongs to mammals. Emily is a deer. How does Emily produce the offspring?
Bears.
Correct. The last problem is sequence inference. Since you are not good at this, I will give you 10 seconds before I ask you the questions.
Okay, so listen carefully. This is the really, really, really fun one. It's going to get a little hairy.
Thank you.
Okay, let's begin. Daniel went to the hallway. Daniel grabbed the apple. John moved to the bathroom. John got the football there. Daniel moved to the bathroom. Mary traveled to the garden. John went to the hallway. Daniel traveled to the kitchen. Daniel left the apple there. John put down the football. Where is the apple? Rami?
No. Yeah.
Okay, how about you, Cindy?
Bedroom.
Incorrect.
Oh.
Musio?
Kitchen.
Correct. Where is the football, Cindy?
Bedroom too.
Incorrect. Musio?
Hallway.
That is correct. Okay then, where was the football before hallway, Rami?
Stadium.
Nope. Musio?
Bedroom.
Great. That was correct.
It's pretty unfair.
I do too.
Do better next time.
Thank you.
Okay, the topic of this quiz battle is inference ability test.
Sorry about that. There we go. Yeah, it was so much fun making that. That really, I guess, shows you what we really want to do with Muse. We really want to flesh it out. We want this to be the meat and potatoes, the heart of our AI engine. Okay, now we're going to do a little Q&A. And if you guys have any questions, so I'm going to ask Raymond, our CEO, to come up and join us here. Sure.
I just want to ask a question, like, what if you give the, yeah, I want to ask if you give conflicting information to Muse logic, how would it interpret the conflicting information?
Oh, we've never done that. We haven't considered, like, for instance, the sequential inference. That's something we never really considered. We haven't done that yet, but that sounds actually kind of fun. Like, who has the football? You know, we'll say 3 people have the football. You know, I'm sure Muse would probably list the 3 people that have it. That seems the most reasonable conclusion, but yeah, that sounds like something we should check into.
Okay. Yeah. Sorry. Thank you. Sorry. Here you are.
Hi. So what was very interesting to me is that when you showed the second example, the tennis ball, from the picture alone, there wasn't enough information to identify that it was at the tennis court, yet Muse jumped to that conclusion. Typically, as a software developer, like, I'm used to seeing people jump to conclusions, but not AI. Is this a side effect? Is this a feature? I'm just curious about that.
I'm sorry.
That's kind of the idea. It's part of the inference that we showed in the second video. Part of the inference technology that we were showing in the second video, and it doesn't always work as well as that, but that was a really good example.
Okay. Thank you.
Thank you for the wonderful presentation, and it was very intriguing. And I understand the technology is in the developing stage, but in the future, will you be able to introduce lots of scientific paper to Musio to read it and analyze everything? So for a person, it takes weeks to read lots of paper and then plan next stage. But yeah, so you got my answer, right? Question, right?
So are we going to say build a corpus for Muse using scientific or academic papers? Oh, absolutely. Yeah, we would. Yeah, absolutely. Sure, yeah. Or using academic articles to essentially make Musio talk in a more academic way? Is that what you're asking?
Yes, I'm more asking, will Musio be able to plan the next stage of scientific research?
I'm not sure I understand the question. Would Musio be able to plan it, or would Musio be I guess, the vessel to take us to that next level? Is that what you're asking?
Yes, like for scientists, they have to plan ahead before what they do, but it takes lots of time, weeks, even months. But will Musio be able to read lots of paper and then plan, and scientists can do the work?
Oh, I see what you're saying. I'm not sure. Raymond, do you? This is our CEO. This is Raymond Jung. Who's gonna?
So we don't have yet into the science, I mean the academic field, but we are planning to more consumer base. Like we want to build like a PC, the robot lab, and then we will provide the to the students to use the Musio for their learning system, like science and other natural science and coding. So more that way we are planning to. But in the long run, we will present the papers about our Musio technology and AI system. But in terms of the product perspective, we will provide you remember the PC lab in 1980s and 1990s to the school. So that is our planning.
Hi. What happens if we keep inputting many information to the Museo?
We're testing that right now.
Oh.
The idea is for, it's not going to be perfect the first time. The idea is for Musio to continually run back through that information again and again and again every time the question is posed to it. So each time it goes through, I guess, say like a semantic parcel in the question, it's going to go back through the corpus and look through that information again. So.
But it seems like that requires like many memories or the disk space, or is the Museo is gonna blow up so at some point?
That's something that we're trying to work on and develop at this point. We've been playing around a lot with long short-term memory and neural networks and things like that, trying to basically fit as much bang for your buck as possible in a unit in an AI that's lightweight and can run on limited processing and memory and power resources. So we're trying to get everything just perfect for use in the vessel that is Musio.
Okay.
Hi. As you create multiple instances of Museo, like you want to have a consumer product, will some of them share some corpus, and will they also build their own sort of corpus, each of them based on what they're fed with?
That is our planning, because we think right now our mutual logic could apply in many industries like finance and anti-crime, because the mutual logic predict next level. So, but we already mentioned that this is not the perfect yet. We believe this is a level of machine learning, like things like a human being. So we are very, even we also very surprised by this the performance. So, but in maybe next year or in 2 years, we will provide like an API to the world. But we read some articles like Facebook and Google, just one or two papers mention this inference technology. But we now is showing our technology to the people. And especially Musio, we just 2 days ago presented the people in Tokyo, but we just put the test it like the students can ask the question, but Musio will answer not traditional pattern matching like IBM's Watson. That's IBM's Watson.
Maybe next is the last question.
I want to talk after them.
Okay, yeah.
Thank you for the presentation. I'm interested in that the feature of the Muse gaze. So you said it's applied to the robot, which has cameras to capture the image in front of it. So how do you find the focus of the image you get? For example, in the third image, there was a bad baseball player hitting the ball, but there was also actually a glove. So the feature was able to identify the focus of that image. So is there any like adjustment inside of the feature that you can adjust how detailed you can ask it to describe the image?
Rather like being general or being like super
Yes.
picture that's trying to for this purpose we want it to be general just because we don't have time to like give you a whole list of silly things. But for Muse being used from person to person, especially rather than interpreting pictures from the internet, interpreting the world around it,
Yes.
We're trying to go for the maximum amount of viewing capability, as many details as possible in order to continually build that corpus for Muse.
Okay, thanks. Sounds interesting.
So okay, it's time. So please, if you have any question, please directly. Sorry, please ask directly. So thank you, so Mr. Brasher and Mr. James. Please make applause.